Hello friends, myself Nimisha. Welcome to ACE Academy. Question is prove that under root 3 is irrational. So we prove this question using contradiction. So we write here solution. Let us assume that under root 3 is rational number. If under root 3 is rational number, then it can be expressed as P upon Q. Therefore, under root 3 is equal to P upon Q, where P and Q are integers and P and Q also co-prime. So we write here P and Q are co-prime and Q is not equal to 0. Now we put this as equation 1. Therefore under root 3 is equal to P upon Q. So we give this as equation 1. Now squaring both the sides, we get here as 3 is equal to P square upon Q square. If you do here square, then this root will be cancelled and we get 3 is equal to P square upon Q square. You can write here as squaring equation 1. So after squaring equation 1, we get here as 3 is equal to P square upon Q square. Now, this Q square is equal to P square upon 3. So we give this as equation 2. Now from equation 2, it is clear that P square is divisible by 3. So we can write here as from 2, it is clear that P square is divisible by 3. If P square is divisible by 3, we can write this as like this. P square divided by 3 we can write as P multiplied by P upon 3. So we put this as equation 3. Now from 3 it is also clear that P is also divisible by 3. If P square is divisible by 3, then P is also divisible by 3. So we can write here as from 3 it is clear that P is divisible by 3. If P square is divisible by 3, then P is also divisible by 3. So from 3 it is clear that P is also divisible by 3. Now we can write this as P upon 3 equal to C. When P is divisible by 3, we get answer something as C. So we can write here as P divided by 3 equal to C. Therefore we can write this as P is equal to 3C. Now we get as P is equal to 3C. We put this as equation 4. Now we put this P equal to 3C, this equation 4 in equation 2. That is Q square is equal to P square upon 3. In this equation we put value of P as 3C. Now we can write here as put P is equal to 3C in equation 2. So we get as Q square is equal to P square upon 3. Q square is equal to, so value of P is 3C. So we can put here as 3C square because Q square will become as 3C whole square upon 3. it will become as 9c square upon 3. So we can write here as 3c square. Q square equal to 3c square. Now it becomes c square equal to q square upon 3. We put this equation 5. Now from 5 it is clear that q square is divisible by 3. So from 5 it is clear that q square is divisible by 3. If q square is divisible by 3, then q is also divisible by 3. We can write this equation as like this: q multiplied by q upon 3. We write this as equation 6. So from equation 6 it is clear that q is divisible by 3. So from equation 6 we can see here q is divisible by 3. From equation 3 we can see here p is divisible by 3. From 3 it is seen that p is divisible by 3, and from 6 it is seen that q is divisible by 3. Therefore we can write here as from 3 and 6 it is clear that P and Q are divisible by 3. If P and Q are divisible by 3, it contradicts our assumption, because we write here as P and Q are co-prime. The meaning of co-prime is that they do not have common factor other than 1. They only have common factor as 1. But P and Q has common factor. That's why they both are divisible by 3. So it contradicts our assumption. So we can write here as, but it contradicts our assumption that P and Q are co-prime. So it contradicts our assumption that P and Q are co-prime. Therefore, under root 3 is not rational number, and therefore it is proved that under root 3 is irrational. Therefore, under root 3 is not rational. Therefore, under root 3 is irrational number. Irrational. Hence, proved. If you like this video, please share it with your friends. Please like and subscribe my channel and press bell icon to get more updates. Thanks for watching it.